All right, so here's the pre-lab for the turntable lab. Um, Here's what you're going to be given here. You're going to be given a wooden disc, okay? And so this is going to be your wooden disc here. It's going to symbolize the wooden disc. And you need to determine the point on that wooden disc. So let's say it's like right here, somewhere about there, where the force of friction is able to keep the little PVC cup in place without it sliding off. So it should stay just right there perfectly still as it swim, or not perfectly still, but it should stay at that radius as it rotates. So as this thing rotates, the cup should stay in the same place on the turntable. Now, to do this isn't very difficult because the centripetal force is the net force here. What you basically just have to do is you just have to find that the centripetal force is equal to the force of friction. Okay? Now, this isn't all that hard to do. You should be able to run some numbers here and calculate what this is. So we know that the centripetal force is equal to mass times the centripetal acceleration. Now, you will not know the straight line velocity, but what you will know is that the record player will be set at a certain frequency. So this will be mass, and you'll have to use this version of the centripetal acceleration, but it will be 4 pi squared. See if I can write that a little better. Back up a little bit. Pi squared F squared R. And that will be equal to your centrifugal force. Okay? Now, what you'll have to do is you'll have to take the mass of your little PVC cup. My electronic balance is in the back. Go ahead and do that. All right. I will show you what the how to deal with the frequency here in a little bit. All right. So that will be given to you. All right. And then what you'll need to do is you'll need to calculate that number, and that's where you'll put your X. Now, all of this side of the equation is equal to the force of friction. Well, we know that the force of friction is equal to F norm times mu. Well, lucky for us, you have run through a procedure several times at this point now where you can calculate a coefficient of friction. All right. Also, you'll have to be able to figure out what the F norm is. Now, because it's a level plane, and it'll be a level plane, no forces will be acting at an angle, the F norm will just be mg, okay, like it has been before. Now, you, like I said, have done this twice already where you run through a procedure and calculated a coefficient of friction. You need to do it again, all right? So that's what you'll have to do first. So you'll take your wooden disc, you will run through the same procedure you've done 2 times to find the coefficient of friction. Once you find that coefficient of friction, you should be able to find that force of friction. Now, remember, that force of friction is equal to the centripetal force. Knowing all of that, you should be able to find a value for R. Okay? And then again, like I said, measure on your disk here where R is. Now, what I do need to tell you is that this record player, so the turntable, will be turning at a specific frequency. That frequency will be 45 RPM. Now, the problem with this is that RPM are not MKS units. Our MKS units, if you remember, are hertz, or those are an event per second or per seconds. All right. Now, in this case, that would be revolutions per second. Now, with this being RPM, all right, the problem is that this would be, the RPM stands for revolutions per minute. What we need to do is we need to get this into revolutions per second. That would be hertz. So in order to get RPM into hertz, what you have to do is simply do a little dimensional analysis. All right, so what you got to do is you're going to have to multiply by a conversion factor. So we can multiply by 1 minute and divide by 60 seconds. When we do that, that gives us revolutions per second, which in this case, that's our hertz. Okay, remember, hertz is number of events per second, and in this case, our event is our revolutions. So this is exactly what we want. So you will need to get your RPM into revolutions per second, which would be hertz. Once you have that, then we can come back here and you'll be able to use this equation again over here, this setup right here, and you should be able to solve for the radius that cup needs to be at. Now, a word to the wise, remember, there has only ever been one group or one person that's ever screwed up this lab. Everyone else has got it to work. Now, what's really cool about this is because it is a because it's static friction, what you're finding here, all right, is that if you were to bump your little cup when it's riding around on here, if you bump it, even if you bump it from the outside just ever so slightly, that will get it moving, and kinetic friction, which is weaker than static friction, will not be strong enough to hold it in place, and so it should slide off the edge. So this is what you want. You want, when it's right there, if you barely tap it as it goes around, just barely with your finger, it should, even if you tap, and you're supposed to tap it towards the middle, it should slide off the edge. And of course, it should take a tangent line as it does that. Okay? Email me if you have any questions. Otherwise, you're going to have to do a lot of the figuring out here on your own, because obviously I'm not here. And good luck.